Okay, Algebra 2 students, here's a video for example 5 for section 3.3. We're going to talk about the binomial theorem. The binomial theorem is very much like Pascal's triangle. It states for every positive integer n that if you have a plus b to the nth power, you can break it down where we have the coefficients c subscript 0, c1, c2, all the way up to c to the n, depends on what n is. That's from Pascal's triangle. The coefficients c subscript 0, 1, 2, 3, and so on are the numbers in row n of Pascal's triangle. What's Pascal's triangle? If you recall, Pascal's triangle looks like this. I think we went down to row 5 or row 6 in an earlier problem. This is all the way out to row 10 if you want to do a screenshot of that. Be my guest. It's going to disappear in 3, 2, 1. Okay, I'm going to keep that handy because I'll probably need that later on. And when you expand, a starts off with the nth power, and then it decreases, minus 1, minus 2, minus 3, all the way down until you don't have any a value at all. And the b values start off with 0, and then they go up in powers, b to the 1, b to the 2, 3, 4, and so far, and so forth, and so forth, so forth, and so forth. Sure. Let's try an example. We're going to have x minus 3 to the 4th power. So it's the 4th power, so we're going to use 4th row of Pascal's triangle. And a is going to be x, and b is going to be negative 3. Once you identify those things, you can plug them into the binomial theorem expansion. Easier said than done. There's the basic expansion. Then they substituted the Pascal's triangle, the 1, 4, 6, 4, 1, because that's the 4th row, in for the coefficients. Now they need to identify what a and b are, which I already have. A is x, and b is negative 3, and then they're going to substitute them in for a and b. Sometimes it's cubed, squared, by itself. So you have to, and when it's a negative number like this, you'll have to be aware of the coefficients changing into negative numbers. First term is x to the 4th. The second one is 4x cubed times negative 3. So the 4 times the negative 3 gives us negative 12 as the final coefficient. Then we have 6 from Pascal's triangle. The x, because that's what a is, x squared, and the b is squared also. So we have negative 3 squared, which is 9, and 9 times 6 is 54. And then for the third, well, this is actually the 1, 2, 3, 4th term. We have 4x to the 1, and negative 3 is to the 3rd power. Negative 3 to the 3rd power is negative 27. Negative 27 times 4 is negative 108. So we have a minus 108x. And then the final term is negative 3 to the 4th power, which is 81. So in conclusion, the x minus 3 to the 4th power can be that. That saves you time rather than have to multiply x minus 3 times x minus 3 times x minus 3 times x minus 3. That would take quite a while. But we've learned there's patterns, so we use Pascal's triangle to find the pattern. Moving on for another example. We have s squared is the a term, and positive 3 is the b term. This time we want to go to the 5th power. So we're going to use the 5th row of Pascal's triangle for the coefficients. Did they do that? 1, 5, 10, 10, 5, and 1. Yep, those are the coefficients. Notice the decreasing values, exponents for a, and the increasing exponents for b. And then you just plug those numbers in. What numbers? You plug in, well, the expressions s squared gets in for a. So right off the bat, when we plug it in, we have s squared to the 5th, so that becomes s to the 10th power. The next one is 5a to the 4th, so 5 s squared to the 4th times b, which is 3. So for coefficients, I have 5 times 3, which is 15, and I have s squared to the 4th, which is s to the 8th. The third one's 10 times s squared to the 3rd times 3 to the 2nd. 3 to the 2nd is 9. 9 times 10 is 90. So you can see the coefficients can change, especially if this is a number. If it's just a letter, we don't have to worry about that so much. But if it's a number, then we're going to have a multiplier times what we get from Pascal's triangle. All right, we have some good ones for us to try here. X minus 1 to the 7th power. So if you forgot Pascal's triangle, you may want to use this right here to tackle that one. And this one's to the 6th power, so you may want to use the 6th row of Pascal's triangle. Okay, I'm going to show you the answers, then I'll show you what the homework is, and then I'll go back and do one or both of these for people who want to see those done out. Okay, so try these if you want. Come back when you're ready. I'm going to show the answers to this first one. X minus 1 to the 7th power ends up being like this. Okay, I'm not going to read all those, but this one has 2 as a coefficient, so that changes things up quite a bit. It's to the 6th power, and it also has variables here and here. The answer you should end up with is this big polynomial. Okay, I'll show you how to do both of these in a minute. First, let me show you what the homework could be. Your teacher could assign you any of these: 18, 58, 59, 60, 61, 62, 63, 21, 22, 20, and 69. For those of you who wanted to see them done out, let's see what we have. Looks like I have answers from my first take, so let me get rid of these. This will take a little bit. I apologize. I will stop it right about here because I do need the 7th row. Here's the 7th row of the Pascal's triangle. So I know A is x, and B is going to be -1. And this is Pascal's triangle, the 7th row. So I start off with 1 x to the 7th power, and B is to the 0 power, so I don't even have this at all. Then I go to the next term, which is 7 for a coefficient, at least initial coefficient. It's going to change, 7, and then I drop this down 1 power, so it's x to the 6th power. But I also have to have this B value to the 1st power, so I have a -1 to the 1st power. Then I have the next coefficient is 21. X gets dropped down to the 5th power, and the -1 now has the 2nd power. I'm going to pause there and show you how that expands out. That stays as x to the 7th power. This, because of the -1 to the 1st power, -1 times 7 is -7, x to the 6. And then the 21 times, well, it's -1 to the 2nd power, so -1 times -1 is +1, so I have positive 21. And it's x to the 5th, and so on and so forth. Final answer was this right here. Okay? Now let me try to do this other one out, or at least give you a head start on it. I need the 6th row of Pascal's triangle, which right now escapes me. 1, 6, I think it's 15, but better safe than sorry. Let me look it up. The 6 rows, 1, 15, 20. So 1, 6, 15, 20, 15, 6, and 1. That's from Pascal's triangle. A is going to be 2C, and B is going to be, as strange as it is, B is going to be D. That's what we have here. All right, for the first term, the coefficient I start off with is 1. Then I need A, which is 2C this time. First time we've had a coefficient in there, and that's raised to the 6th power. Plus, oh, and there was no D. There was no B value. Now for the next one, here's the starting coefficient is 6 times 2C to the 5th power. And then the B value, which is D, is to the 1st power. Then the next term, 15 and I have 2c this time to the fourth power, because that's going to keep decreasing, and my b value keeps increasing for an exponent. So this time I have d to the second power. And this goes on and on and on, but let me expand this out and then I'll show you the final answer again. 2 to the 6th power, 2, 4, 8, 16, 32, 64, I believe, is 2 to the 6th power. So 64 times 1, and c to the 6th power, plus we have 6 times 2 to the 5th power, 2, 4, 8, 16, 32. So I have 32. 6 times 32, I think is 192. And then we still have c to the 5th power. And d shows up now. And for the rest of this, c is going to be reducing in exponents and d is going to be increasing in exponents. The coefficients are kind of important. We have 15 and we have 2 to the 4th power. So 2, 4, 8, 16 is 2 to the 4th power. And 16 times 15, oh, I don't know. 15 times 16. 240 or something. 90. Okay, 90. That wasn't even close. Did I do that right? No, I didn't do that right. 15 times 16 is 240. Oh, okay, good. 240. And c is to the 4th power, and the d is to the 2nd power. And it goes on and on and on. You should end up with an answer like this mess. Okay? If you forgot what the problems were that you could be assigned, here they are again. That's it for this video. Have a great day.